Hi, my name is Carl Walenciak, and I'm on a team with Brian Waite, and our project is maritime wind speed prediction using Buoy LIDAR data. Our goal is to forecast wind speed at a theoretical wind turbine 10 minutes ahead using historical wind and meteorological data. The U.S. energy grid requires a constant balance between generation and load, and because of the variability in wind production, it makes it difficult to integrate into the system. Also, constant starting and stopping of turbines puts a lot of wear and tear on conventional plants. So we're using the Buoy LIDAR data from the Pacific Northwest National Labs, and it collects comprehensive meteorological and oceanographic data. It's using LIDAR, and LIDAR stands for light detection and ranging. This shows a realization of our data set from April 20th, 2016 at 1 minute intervals. And here we have the red bar that shows the mean of the data set. And when we look at it, we do see some evidence of wandering in the realization. These are all the realizations from April 1st to April 20th plotted all together, and they're also at 1 minute intervals. Here we have the spectral density and autocorrelation from our realization. As you saw on the last slide, we had very slowly damping ACFs, and so we decided to difference the data. And the realizations do appear to be white. The ACFs drop off after about 2 lags pretty abruptly, and so it appears that we have an MA model here. And then when looking at the AIC and BIC, we do get a 0.2 for the top selection. We did fit an MA model, but because it's not typically representative of the real world, we went with the ARMA 2.0 model. And here's our final model. We have a ARIMA 2.1.0. And looking at the residuals, they do appear to be white. We checked it with the Young box test at k equals 24 and k equals 48, and both failed to reject the null hypothesis. And here we forecasted with our ARIMA model. You can see it's pretty much forecasting the last observed value forward, which is typical of a route on the unit circle. We did get an ASC of 0.0505. Now we're moving on to our vector autoregressive model. And here we have 4 exogenous variables, which is the horizontal wind direction, temperature, barometric pressure, and humidity. One of the issues that we had was that the data wasn't collected at the same time interval, so we did do some linear interpolation to get them on the same time interval. We used var select, and the AIC indicated a k equal to 12, and so that's what we went with. And here we forecasted, and you can see that it does capture a little bit more of the up and down as well as the trend in the data, and the ASC is improved to a 0.041. Now we're moving on to fitting a neural network model, and we did attempt to initially fit a multivariate model, but we were getting worse ASC results. And on top of that, when we added more variables and complexity to the model, it increased our training time significantly, and that became problematic when we're only dealing with forecasting 10 minutes ahead in a real-time situation. Here's our forecast with our neural network model, and it appears to be similar to the ARIMA model. We do get an ASC of 0.055. Our final model is the ensemble model, and it is just a simple mean of all the 3 previously forecasted models. And it does seem to be a good balance between the capturing the trend of the VAR model, and then the difference dominated ARIMA and neural network model. And we got an ASC of 0.0369. Here we have all the ASCs together. So we have the ASC on just one forecast, but then we also did a windowed ASC, and we had 1,000 iterations of it. And you can see that the ensemble model wins on both of them at 0.0369 and 0.119. So based on our analysis, we think the ensemble model is the best way to move forward with predictions. And we did see the dominance of the 1 minus B factor, showing that probably the best forecast for wind is very near to the last observed value. We would caution that the neural network, while powerful, can become problematic because of the long training time. And these are references for our research.